Good afternoon, students. Today we're going to be talking about projectile motion. And before we proceed, I need to explain what a projectile motion is, so it creates a basis for our learning today. A projectile motion is a form of motion experienced by a body or an object that is projected near the earth's surface and moves along a curved path under the action of gravity only. So this means that a projectile motion is only influenced by gravity. So when you have a motion whereby it is not influenced by gravity or not governed by the law of gravity, then it is not a projectile motion. That's the first key point. Now we have this. This is our y plane and this is our x plane. So our horizontal and our vertical. So it means that the body or the object is projected like this and goes like this. Now when you have something like this thing is projected at a particular angle with a particular speed, which could be called your initial velocity. At every point here you have both your vertical and horizontal components. Why? Because this is an inclined motion. So we have it having both the horizontal and the vertical component of your initial velocity, except here at your maximum height here h. This is where you have your vertical velocity is equals to what? Is 0, because it stops here. All you have here is just what? Your ux. That's your what? You only have your ux here. And if you look at this using our linear trigonometric functions, we have, if I have an angle here theta, I have u here, and I call this my y and this is my x. We could say that this is ux, uy, ux. So we have sine opposite hypotenuse. So we could say that sine theta is equal to our opposite, that's uy, over what? Hypotenuse, that's your u. So my uy can be called what? U sine theta. Also same goes for my ux. I have what? This adjacent and this hypotenuse. So I could say that cos theta is equals to ux over u. So my ux is equals to u cos theta. Now so it means that everywhere I have ux here, it is u cos theta. So it's representing what? The horizontal component of my initial velocity. So with this now, we could say that as this body goes up, it has to come back down here because it's being governed by gravity. At this particular point, it stops and it starts returning. This point whereby the body stops is called your what? Maximum height, h max. And the time taken for it to get to this maximum height is recognized as your small t. So we call it our time taken to get to our maximum height. Now ideally we say that when a body is projected, the time taken to get to this maximum height is the same time taken for it to what? Return back to the plane of projection, because this is our plane of projection. So we call this place also what? Small t. So we have here a body is moving from here and it's being projected from here and it landed at the other side here. So this whole horizontal distance here, the distance from your point of projection to your point of landing, is called your what? Your r. And that is called your what? Horizontal range. So if I'm now trying to look at it, that what is the total time taken for this whole motion, we call that what? Our big T. And that's the time taken for it to move from here to this point. We call that our what? Our big T, and that's our time of flight. Now projectile motion is very easy if you pay attention to the details in it. Number one, you need to understand that the motion is governed by gravity. It might be projected at an angle or horizontally or vertically upward, depending, but at every point in time it is governed by what? Gravity. If it's projected horizontally, then it means that for you to throw a body like this, it will get to a point whereby it starts falling. At that point whereby it is falling, then gravity is involved. Or if an object is going upward, gravity is what? Involved. Either going vertically upward or falling, or going at an angle upward, gravity is involved. So if an object goes like that, then it has to still come back down. Just love gravity. So now, looking at all this, we have our vertical distance, that's your what? Height. And you have your horizontal distance, that's called your what? Horizontal range. Okay, so if you could recall that we have what we call our equations of motion. We have our equations of motion. The first equation of motion, v is equal to u plus at. This is for linear motion. The second one, s is equal to ut plus half at squared. The last one, v squared is equal to u squared plus 2as. Now, these are equations of linear motion. So, having that, so we have that. These are equations of linear motion. Now, if you look at it, they are linear motion. Why? Because there is no parameter indicating gravity here. So, if we equation of motion under gravity now, we have our v, we have our u, and our a and our s are the only things that change. Why? Because we won't be considering a linear acceleration again. We'll be talking about what? Our a changes to what? Plus or minus g. What changes of the plus or minus g? In vector notation, let's look at it. How does that gravity act? Gravity acts downward on the surface of the earth. This is the direction of gravity. In vector notation, when something goes against the initial position, it is negative. But when it goes in direction, in the initial direction, that makes it positive. So if a body is coming downward, or if we say a body is falling, then we can say that the acceleration due to gravity there is positive. When a body is going upward, going against gravity, then the acceleration due to gravity is negative. That's why we have plus or minus g. Our s, our horizontal distance, we could call it h, sometimes x or y, depending on what we are trying to look at. So now I could rewrite this as v is equal to u plus or minus gt. I could call this h is equal to ut plus or minus half gt squared. We have v squared is equal to u squared plus or minus 2gh. Now, looking at this from this perspective now, we could use this to solve when angles are not involved. Like when we are not trying to consider the angle being used. Let's assume that a body is thrown vertically upwards or a body is projected horizontally. So we could use this. Now, let's check something again. Now, if you look at the diagram I just cleaned, okay, let me draw a very small one here. U, and I said at every point it has both vertical and horizontal components here. Now, if I'm to consider this particular diagram motion and I want to get my formulas using this angle, we need to look at it. If this body is going upward and we are trying to get our time of flight, time to get to maximum height, small t first. If this body is going vertically upward, at your maximum height, your final velocity is equal to 0, because at this point it stops moving. So we can say that v is equal to 0 using our first equation of motion. Now, looking at this, we are considering what? An upward motion. So we'll be using what? Our vertical velocity, initial velocity, and uy is equal to u sin theta, ux is equal to u cos theta, if we didn't forget that. So we have, using that, so we have z is equal to, this will be our uy. Now, because the body is going upward, our acceleration to gravity will be negative, going against the initial direction of gravity to negative t. So what do we have? We have minus uy is equal to minus gt. So we could say that divide both sides by g. So my t will be equal to uy over g. So my t is equal to uy, and my uy is u sin theta over g. Since we said that our time of flight, big T, is equal to twice this one, so we have 2t, and that's equal to 2u sin theta over g. That's 2u sin theta over g.
So we have that. Now, other thing we could look at is this. We mentioned quite a lot of things. We see have our maximum height and our horizontal range to deal with. So what is our maximum height from here? Using our third equation of motion, since we are dealing with our vertical motion, so we have to consider this. So we have at our final velocity, our v is equal to 0 as maximum height here. Our final velocity is equal to 0, so we have this. So we have 0 squared is equal to uy squared minus 2gh. So we have minus uy squared is equal to minus 2gh. So I can see that my h is equal to uy squared over 2g. So this is my maximum height, and my maximum height will be equal to uy squared. What's my ui? My ui is u sine theta all squared over 2g, and that gives us u squared sine square theta over 2g. That's done. Now the last one, we deals with our range. First thing first, our range is called the horizontal distance, right? So since it is the horizontal distance, our g here is not required. Our g here is not required. So what do? And we need to know that our range is from here to here. So the total time taken for our range is the time of flight multiplied by what? Your horizontal velocity. So we see that here, what we have here, h will be called what? R, and that's equals to ux big T. So what do we have? We have our r is equal to ux. Our ux is u cos theta multiplied by our big T, that's 2u sin theta over g. So our r is equal to 2u squared sin theta cos theta over g. So from our trig function, we have a function that says that sine 2 theta is equal to 2 sin theta cos theta. So if we try to apply that here, we have r is equal to u squared multiplied by 2 sin theta cos theta over g. So looking at this, we could replace 2 sin theta cos theta with this. So we have r is equal to u squared sin 2 theta over g. This is our range. Now, at what value do we say that our range is maximum? If I put in, for me to get the maximum range, this particular factor sin 2 theta tends to reduce the value from getting the maximum value until you get this factor to be 1. That is when you can get your maximum range. That's when you can get your maximum range. So it means that what value of theta will give me sin 2 theta to be 1? So we know that sin 90 gives us 1. So that means that the value of theta we need is 45. So at theta equals 45, what we have is what? Our maximum range. That's u squared sin 2 into bracket 45 over g. That's u squared over g. So this value gives us our maximum range. So I want us to try some examples, some questions. So we would see how projectile questions are being solved. Okay, so I have some questions here. Now, so let's look at this. We're given a diagram, and this is Alice. So the question says, in the given picture below, Alice threw the ball to the x plus direction, the positive x direction, yeah, with an initial velocity of 10 meter per second. 10 meter per second. Full stop. The time elapsed during the motion is 4 seconds. So it is 5 seconds. So that means that the time taken for this ball to get down here is 5 seconds. So my t is 5 seconds. Calculate the height at which the object is thrown and the y component, the vertical component of the velocity after it hits the ground. So what they want us to give them is the vertical component of the velocity after it hits the ground. So how do we go about that? First thing first, our ux, we're given an horizontal velocity. That's our initial velocity, and the time is 5 seconds. So what they want us to give them is what? They said we should give them the height. They said we should give them the height. So let me put down the question here so it will be easier for us to identify with the question. So with this now it's easier for us to identify with the question. So the first thing they want us to get is the height. Now remember from our second Newton's law of motion, equation of motion, sorry. So we have our ut plus half gt squared. Now if you consider this type of motion, this body is falling downward and this is a vertical component of your initial velocity, and from here you can see that the velocity that we're giving was the horizontal, so it means that our uy is equal to 0 meter per second. So applying that, now we have our I to be equal to 0 multiplied by 5 plus 1/2, taking our g to be 10 meter per second squared. We have multiplied by 5 squared, so we have h is equal to 0 plus what? Here is 5, so we have 125. So our height is 125. So that is from where the object was thrown downward. Our h is what? 125 meters. Now how do we get the vertical component of the final velocity? First thing first, vy, we have what? Uy plus gt. It means that using this now, everything is all forward in vertical motion. Remember that our uy is equal to 0, so we have vy is equal to 0 plus 10 multiplied by 5. So our vy is equal to 50 meter per second. So we will see the first one is calculate the height at which the object is thrown, and we have it as this, and the vertical component of the final velocity after it hits the ground. This is it. So this answers this particular question. So we can see that everything is based on the application of what we've learned so far. Just the application of the laws and understanding what the question is about. Is the body falling with gravity? What am I giving? Am I giving my initial velocity as the initial velocity, or am I giving the initial velocity as the velocity or the horizontal initial velocity? So we need to understand all these concepts so that we would be able to achieve all this. So I will be stopping here for today.